Scene script. Have you ever heard of the Cascadia Subduction Zone and wondered what exactly it is? Well, to understand this, we need to venture into the world of plate tectonics and subduction. Our planet's outer shell, the lithosphere, isn't a solid piece. Instead, it's a jigsaw puzzle of massive slabs known as tectonic plates. These plates, which carry continents and oceans, are constantly moving, albeit at a snail's pace. Now imagine two of these plates converging, but one is denser than the other. What happens? The denser one sinks beneath the lighter one, descending into the Earth's mantle. This process is what we call subduction. Subduction is a fascinating and complex phenomenon. It's like a slow-motion, planetary-scale recycling program. Here, the oceanic crust, formed at mid-ocean ridges, returns to the mantle from which it was born. Over millions of years, this process helps shape our Earth's surface, giving rise to deep ocean trenches, volcanic arcs, and even majestic mountain ranges. While subduction zones are scattered worldwide, each has its unique characteristics. Take the Mariana Trench in the western Pacific, which is home to the deepest subduction zone on Earth, plunging an incredible 7 miles below the ocean surface. Or consider the Andes, the longest continental mountain range in the world, a product of the ongoing subduction of the Nazca Plate beneath the South American Plate. Now let's bring it closer to home. Off the coast of the Pacific Northwest, we have our very own subduction zone, the Cascadia. Here, the small but dense Juan de Fuca Plate is pushing eastward and sliding beneath the much larger North American Plate. This process has been going on for millions of years, giving birth to the beautiful, yet potentially deadly landscape of the Pacific Northwest. Subduction is a powerful force, and it's the driving factor behind the Cascadia Subduction Zone. Understanding this natural process is key to grasping why we live in a world of constant geological change. So, buckle up as we delve deeper into the world of subduction and the mysteries of the Cascadia Subduction Zone. Now that we know what subduction is, let's dive into the specifics of the Cascadia Subduction Zone. Imagine a colossal slab of oceanic crust known as the Juan de Fuca Plate, extending from northern California to southern British Columbia. Now visualize this plate sliding or subducting beneath the enormous North American Plate. This intricate dance of tectonic plates happening right beneath us is the heart of the Cascadia Subduction Zone. At the surface, you might not see much, but deep below, spanning more than 700 miles, there's a constant, intense tussle. The Juan de Fuca Plate, burdened by the weight of the Pacific Ocean, grinds slowly yet determinedly against the North American Plate. The pressure builds up over hundreds of years, locked at the plate boundary until it's too much to bear, and then, in a matter of mere seconds, it releases. The result? An earthquake. The last major quake in this region occurred back in the winter of 1699. It was a chilling January night when the ground beneath the Pacific Northwest shook with a fury that was felt as far away as Japan. The quake, estimated at a magnitude between 8 and 9, triggered a tsunami that washed ashore on the coasts of California and Japan. Its seismic echoes were so powerful that they were recorded in tree rings and sediment layers, creating a geological snapshot of a catastrophic event. The Cascadia Subduction Zone isn't just a historical curiosity. It's a living, breathing seismic beast that could awaken at any moment. Scientists estimate that there's a 1 in 3 chance of a significant quake occurring in the next 50 years. The potential quake, which could reach a magnitude of 9 or more, would be accompanied by violent shaking and potentially catastrophic tsunamis. It's a sobering thought, isn't it? But why should we care about the Cascadia Subduction Zone? It's because the stakes are high. This region is home to millions of people and critical infrastructure, from bustling cities like Vancouver, Seattle, and Portland, to important ports, airports, and highways. A major quake could disrupt lives, economies, and ecosystems on a scale we've rarely seen. The Cascadia Subduction Zone is a stark reminder of the dynamic and sometimes volatile nature of our planet. It's a place where the slow grind of geological time intersects with the rapid pace of human life. It's a seismic hotspot that deserves our attention and respect. The Cascadia Subduction Zone is a significant seismic hotspot, with potential for powerful earthquakes. You've probably heard of the infamous San Andreas Fault, but how does it compare to the Cascadia Subduction Zone? Well, let's dive right in. The San Andreas Fault and the Cascadia Subduction Zone are two of the most well-known seismic regions in North America, but they're as different as night and day. The San Andreas Fault, stretching over 800 miles through California, is a strike-slip fault. This means the Pacific and North American plates slide past each other horizontally. When they get stuck and finally release, we experience an earthquake. On the other hand, the Cascadia Subduction Zone, off the Pacific Northwest coast, is a completely different beast. Here, the Juan de Fuca plate is forced under the North American plate in a process called subduction, hence the name. When the tension finally gives way, it results in a megathrust earthquake, often accompanied by tsunamis. These are much more powerful and devastating than the quakes produced by the San Andreas Fault. Geographically, the areas impacted by these two fault zones are also different. The San Andreas Fault affects a long but relatively narrow strip of land along the California coast. In contrast, the Cascadia Subduction Zone has the potential to impact a much larger area, stretching from Northern California all the way to British Columbia. This includes major cities like Seattle and Vancouver, and numerous coastal communities. However, it's important to note that while the Cascadia Subduction Zone has been relatively quiet for over 300 years, the San Andreas Fault has been consistently active, with notable quakes in the late 1800s and mid-20th century. So, while the San Andreas and Cascadia might seem like apples and oranges, the one thing they have in common is their potential for causing significant seismic events. It's not a matter of if, but when they will strike next. While they are different in many ways, both the San Andreas and Cascadia zones pose significant seismic risks, so it's crucial to be informed, prepared, and ready to act when the Earth decides to shake things up. What happens if a major earthquake strikes in the Cascadia Subduction Zone? Picture this. The ground starts to shake gently at first, but then with increasing force. Buildings sway, roads crack, and in the worst-case scenario, the ground beneath us could even open up. This is not a scene from a disaster movie. This is what could happen if a major earthquake were to occur in the Cascadia Subduction Zone. But the shaking is only part of the story. You see, when the Juan de Fuca plate grinds against the North American plate, it doesn't just cause the Earth to tremble. It can also trigger tsunamis. Imagine a wall of water tens of feet high hurtling towards the coast at jet speed. Coastal towns could be flooded in minutes, causing untold devastation. And then there's the aftermath. The shaking earth and the tsunami waves could cause serious damage to infrastructure. Roads might be impassable, bridges could collapse, and utilities like water and electricity might be disrupted for days, weeks, or even months. High-rise buildings not built to withstand such force could crumble, leaving behind a trail of destruction. But this scenario is not inevitable. We can take steps to mitigate the impact of such a disaster. That's where preparedness comes into play. By understanding the potential risks and planning accordingly, we can significantly reduce the potential damage. For instance, we can strengthen our buildings and infrastructure to withstand the shaking. We can develop early warning systems to alert us before the shaking starts, giving us precious seconds to seek shelter. And we can map out evacuation routes to help us get to higher ground before a tsunami hits. Moreover, we can prepare our communities by storing emergency supplies, developing communication plans, and practicing what to do when an earthquake strikes. It's about being ready, so we can respond quickly and effectively when the time comes. Preparedness is key in mitigating the impacts of a major earthquake in the Cascadia Subduction Zone. How do we measure the power of an earthquake, and where does a potential Cascadia quake fit on that scale? This is where the Richter scale comes in. It's a logarithmic measure that assigns a magnitude to quantify the energy released by an earthquake. Imagine it like this. Each whole number increase on the scale represents a 10-fold increase in measured amplitude and roughly 31.6 times more energy release. For example, a magnitude 5 earthquake releases 31.6 times more energy than a magnitude 4. Now let's take a stroll down memory lane. The Great Chilean Earthquake in 1960, the most powerful on record, hit a whopping 9.5 on the Richter scale. Fast forward to the present, and scientists predict that a major quake in the Cascadia Subduction Zone could reach up to magnitude 9. To put it into perspective, that's about 1.5 times less energy than the Great Chilean Earthquake. A Cascadia earthquake could be one of the most powerful seismic events in recorded history. Understanding the Cascadia Subduction Zone is not just about science. It's about safety. We've journeyed through the depths of our planet's crust, explored the complex dynamics of tectonic plates, and highlighted the potentially cataclysmic forces simmering beneath our feet. The importance of this knowledge is underscored by the fact that these subduction zones, particularly the Cascadia, can unleash earthquakes of staggering magnitudes. The comparison with the San Andreas Fault Zone only underscores the immense power of these geological phenomena. But remember, this discussion is not meant to incite fear, but to foster preparedness. Embrace the opportunity to learn more about earthquake readiness. There are countless resources out there to help us understand and prepare for these seismic events. Websites, emergency contact numbers, evacuation routes, these are just a few starting points. Knowledge is power. Stay informed, stay prepared, and stay safe.